This conference will now be recorded.
Dear students, I am ESV Subramaniam, Associate Professor in Chemistry, BBC Engineering College, Vadalrev. Now, I am going to give a video lesson on Joule-Thomson effect. What is Joule-Thomson effect? When a gas from high pressure region is passed through a porous plug into a low pressure region, the temperature of the gas falls down. This is called Joule-Thomson effect. The cooling effect is due to the fact that during expansion, the molecules of the gas are torn apart against their intermolecular attraction, and some energy is required for this purpose and is taken from the gas itself. Now a question arises, why the energy for the required for the expansion is taken from the gas itself? We have to understand that this Joule-Thomson expansion takes place at constant heat conditions, that is adiabatic conditions. So no heat is allowed into the system, or no heat is allowed to pass out of the system. So the temperature of the gas will fall down. It has been observed that the Joule-Thomson effect becomes smaller as the gas approaches ideal behavior, and in case of ideal gas, Joule-Thomson effect is zero, because in an ideal gas, van der Waals forces of attractions are very negligible, and there is no expenditure of energy in overcoming these forces during expansion. Now, what is meant by inversion temperature? Every gas will have a temperature called inversion temperature. When a gas is subjected to Joule-Thomson expansion, only below its inversion temperature, we get cooling effect. All the real gases like oxygen, nitrogen, carbon dioxide will have very high inversion temperatures. So when Joule-Thomson expansion takes place at room temperature, they get cooling effect. On the other hand, if you consider hydrogen and helium, they have the inversion temperatures very low, that is minus 80 degrees centigrade and minus 40 to minus 240 degrees for hydrogen and helium respectively. So when Joule-Thomson expansion takes place for these two gases, we get a cooling effect in we get we get we get a heating effect instead of cooling effect. So it has been observed that for every gas below which only that below the inversion temperature only we get cooling effect. Since these two gases have very low inversion temperatures, we get heating effect during Joule-Thomson expansion. But if hydrogen is cooled below minus 80 degrees centigrade and helium is cooled below minus 240 degrees centigrade, and if Joule-Thomson effect is conducted, again we get a cooling effect. This inversion temperature is dependent upon van der Waals constants A and B. We all know that the van der Waals gas equation is P plus A by V square into V minus B is equal to R, where A and B are called van der Waals constants. This inversion temperature represented as Ti is given by the equation 2A by RB, where A and B are van der Waals constants. Now, what is Joule-Thomson coefficient? In order to understand what is meant by Joule-Thomson coefficient, let us look at the following diagram. here we consider a cylindrical vessel made of non-conducting material. A porous plug divides the cylindrical vessel into two parts. What is porous plug? It is a non-conducting material like plastic having small holes. In the left compartment, we keep a gas which is having pressure P1, temperature T1, and internal energy E1. We are fixing a piston A which has weightless and frictionless nature. Now, on the right hand side, we also fix a weightless frictionless piston B. Now, if you move the piston from its position through a volume of V1, then what happens? The gas will be subjected to compression. We will move the piston from its position through a volume of V1 very slowly, and then there is no change in the pressure or temperature of the gas. Now, when the gas enters the other compartment through the porous plug, its pressure becomes P2, temperature T2, and internal energy E2. Now, it moves the piston through a volume V2. Then the work done on the gas will be P1 V1 and work done by the gas will be P2 V2. So that the net work done by the gas will become P2 V2 minus P1 V1. But E2 minus E1 is equal to Q minus W according to first law of thermodynamics. But here Q becomes 0 because the expansion is taking place at adiabatic conditions. Therefore, E2 minus E1 is equal to minus W, which is equal to P1 V1 minus P2 V2. Rearranging the terms, we will get E2 plus P2 V2 is equal to E1 plus P1 V1. We know that E plus PV is equal to enthalpy. Therefore, we can write H2 is equal to H1. H2 is the enthalpy after expansion and H1 is the enthalpy before expansion. Therefore, change in enthalpy is 0. So we can say that Joule-Thomson expansion takes place at constant enthalpy conditions. Now, we define Joule-Thomson coefficient mu as the rate of change of temperature with respect to pressure, and it is represented by the symbol mu. So mu is equal to delta T by delta P at constant enthalpy. If there is fall in temperature, mu will get positive sign, and if there is increase of temperature, mu will get negative sign. And the condition where mu is equal to 0 is called inversion point, at which there is no heating or cooling. This is about Joule-Thomson coefficient. Thank you.